In this video, I will quickly show how to reuse a previously built distro within our PscgBuildOS projects. This comes after a question that somebody asked in the recent meetup in 2024, March 31st, and they asked, "Hey, what if I want to put Alpine on it?" So I told them it's not a problem. You're going to do it like in a couple of minutes, or maybe I even said a couple of seconds. But now it's time to show it, okay? So for that, I will show how you quickly hack things. But before that, let's do a quick recap on how I actually test it or how I run an emulator. So basically, this script, which is called run-qemu, what it does, it checks what is the architecture of the target, because this is where it will run our boot materials, which means kernel, QEMU, BIOS, that would be like our bootloader, and an init ramdisk, which will help us to run the flashing software and to route the logic of whether we want to go to operational user space, or we want to flash or things or so, okay? So basically, there are a couple of environment variables that we will be setting, mostly what distro we want to use, and I will show you a distro that has like a boilerplate code that you can just use or change in order to reuse kernel and ramdisk from another built distro. I called it a build image materials. And the other thing would be actually selecting an installer image based on it. Why? Because we're going to take such an image that should be DTable to our movable media and flash it into, at the beginning, an empty file, into a file that will have a partitioning that we treat as an eMMC. We do things that are very simple on the QEMU front, so we don't do too much. But so when we use we use regular network materials, like we use a slurp, we don't use tap devices. This is called QEMU user mode. And I will not go into too many explanations. I just want to step to the core of what I want to explain. The build system, the testers will be covered in other places. Important thing is that the first storage param, like to be HDA or VDA, depending on your storage driver in QEMU, will be used for the eMMC image file, and the second one will be for the installer image, which means that we can provide several installer images, install them on the eMMC, and run different systems. So the installer images will look something like this. If I look like at the shared artifacts, this is how I like to call it in case I build it from a system, from a Docker, so on. I will have the distro, the architecture, then the name like installer and image. So here I have like a couple of them. And the one that is currently installed is let's see what is currently installed. Is a Debian file system that has a root, okay? And we can see that it uses around 400 megabytes. This does not overlay, this does not do overlay and things like that. This is deliberate, okay? So my objective is to use another kind of like installer and then do some other things in that. Now, if we go to the code that I want to show you, hey, this is like how you change something like very, very quickly. I want to show you a couple of things. I'm not covering the entire build system, but you can add your own distro and copy from this template. You'll put standard distro, the name, it always has to start with psg underscore something at the moment. And then however you want to call it, you'll need to have the same file.buildconfig as the folder. And you'll have a build distro script. They use a common build distro file. And the common file calls a couple of functions that a distro that you implement, we can call it a derived distro, it implements these functions that are being called. So the config file is a line or two. Let's have a look at it. We source a common file. You can use it as is. And what I have here is the following. I want to provide a build material directory, okay, where I will have a kernel that is already built. I just want to, in this example, to reuse the user space, but I can actually also build them. There are some configuration variables that say what it is exactly that I want to build. And an init ramdisk and maybe a bootloader and a root file system. So in this particular example, I'm just going to reuse the root file system. This is the reusing method. And copying means copy from the other rootfs. The other thing that I can do would be symlink, which will do ln-s, or hardlink that will only work on the same partition. Okay. So this is the config file. And the distro file will look like this. So there are comments, you will see it when I upload the code, but we take a system that is already built. In this demo, we'll use PscgBuildOS, but it is a configuration environment, as you'll see when I build. We copy the root file system from it, and we use the rest of the things, ramdisk and kernel. Here we add some minor but noticeable additions. When I say noticeable, here, for example, we add debian, and we add like this a message of the day, an issue, and so on. And we add login. So here we'll change some of the things. And we'll override only the functions that we need to override. So these are some things that I might change. I said that there is like a pre and post rootfs building phases, and they are specific to the distro, and perhaps I will just do something else. So these macros just say, hey, define local whatever file name and use it as the function. Source specific configs would be, hey, instead of just sourcing the current distro config, maybe add some other config files that you want to source. It can have environment variables and functions. And build distro add rootfs layers, you would do it after the pre-pass phase. The pre-pass would, for example, in Debian, do the bootstrap. For example, in busybox.os, we'll build busybox, for example, or copy a ramdisk into it. And the rootfs layers, you can use add layer to add some layers as we've done, like in PscgBuildOS. Now here, the intention is to hack, right? This is why we call it PSCG Quick Hack Linux OS. So we'll do two things instead of like layers. We'll call a function that modifies a hostname, and we'll call a function that does some other modifications. And pay attention to this. This is rootfs dir, which is used over the build system, and this is distro image material installable system dir, and both are the same, meaning that these two fellows will find themselves having a folder that will be packed by the imager into system image, which is an ext4 image. Okay, great. So let's see what we have here. What we have here, the implementations of these ones in the first demo, before we do like something quick for the Alpine, would just be putting a version under the PSCG distro release file. Okay, we keep the OS release intact, so if it's like Debian or other things, then we can see what was like the base. And look what we do here also in the other function. We're going to set root auto login by overriding whatever is over there. Okay, console dev is a parameter. If it's ARM, it's probably will be TTY AMA 0. And in this case, I'm showing on Intel because I have like an Intel laptop, and I just wanted to boot very fast. So that's how I wanted to decompress things faster, of course. So this is what I do. I use KVM, and I'm happy with it. And here I get rid of the default. I use finit as the framework, finitsysv, and I just get rid of all the other terminals. Say, okay, I don't care about anything. I just want auto login on wherever my serial device is, and that's it. And the other thing that I do is removing if the previous shell is dash, for example, in canonical or in Debian, then I put the default sh to be bash. Why? Because it's noticeable and because I want to. Okay, so these don't do much, and let's see what happens when I want to go ahead and install it. So back to our terminal here. So we'll put here PSCG. Let's see how I call it. Quick hack Linux OS. And I'm going to put some kernel command lines that will say use installer. This is the most trivial part of installer. No AB, just flash it and that's it. So I'm going to do it. And I also hacked it to not remove partitions, use the exact same partition layout, doesn't matter. When it works, we have like this light bulb, like otherwise maybe I would play some sound or like a flash a LED on a device, and that's what I have. And here, like, here's the thing, I'm using it as a removable media. So if we put a removable media and restart and things load from the removable media, then perhaps they will install again. This is why every installer will say, hey, before shutting down, remove the removable media. Okay, so I'm taking note of this, and the next time I run it, I actually don't wait for the removable media, and actually don't need any of these command lines at all. And let's run it and see what's going on. So run, and voila, see, first of all, it's not a DevOS, it's this one, okay? We see this change, and we see this line that we wrote. This is why we did not even have a login here. So awesome. First thing is done. We managed to flash something, which is pretty nice. And just because it's so fast, I will show you what happens like if we put like the busybox OS, which is what we showed in some of the previous embedded Israel meetups. So I'll flash it, then I will run it, and then it will boot like directly to busybox. But here I add some things in the busybox init. This is why I chose it, but this is for another time, not for like right now. So this is where we have it, and it's okay, and it's fine, it's nice. Now, one of the reasons I'm mentioning it is because some people say, hey, what if we want to put like Alpine? So Alpine actually uses busybox. So if we understand how the busybox init file works like, then we understand how to make Alpine work. Now, first I will show, just for the fun of it, what happens if we try to do something naive with using Alpine, but we don't bother to configure like our login properly. So what I did here, I modified the build rootfs prepass here. And look what I'm doing here. I actually go get the tarball. When I do it like, like write distro properly, I will also make sure that this goes into a caching directory. But here I'm just faking it. Look what I'm doing. I already had a pre-built rootfs. I only added one function, and then I cut it short with return, like the flow of this script. So I get a tarball. I remove the previous root file directory. I create just the rootfs directory. I create just the directory, and then I extract the tarball to that root directory, and then the image will be packed and everything will be okay. So let's go ahead and run that. So it's the same distro name. I'm telling it that I copied the materials from this directory. Build blah 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 image material work here, and then it goes until the build hack. Okay. So the material work here looks something like this. It has installables, and then it has like something where a fat partition will be associated. Ext images, where I will put a system, not the system image itself, but the root file directory. This will be packed. And if I want, I can put some overlays, readable overlays, writable overlays, that does all kind of things that are not for this lecture. Okay, it will be like the more advanced stuff. Tons of trade-offs. I mean, it's not that advanced if you already know what I'm talking about, but if you're new to it, and the purpose of this series is to tell embedded Linux folks, to tell like microcontroller folks, hey, you're going to be amazing embedded Linux engineers, and it's not that scary. So I don't expect people to know things. I'm building like the background and the materials from scratch, to be honest. So I'm going to build this, and it will ask me, hey, are you sure? Yeah, I'm sure. Why not? Here is the downloading. Those red things is because I say, hey, I allow you to get all kind of other pre-builds. To MPS, maybe no. And then it will create an imager. And when the imager is done, I'll be able to install it, which is what I'm going to do. So I will install the PscG QuickCast Linux distro. Actually, accidentally hit enter to reboot instead of removing it first. So it works well. And now I'll do the run-qemu, and let's see what's going on. So look what's going on. First of all, this is Alpine, so it wants to use OpenRC. But the minimal root file system was not configured for that. So nobody is really like doing anything about opening the terminals. So we're sort of stuck here. So there are several solutions for that. And one of them would be, of course, I know the system because I wrote it, to stop like in the middle. So I'm going to do this. I added all kind of like command line hacks that say stop at ramdisk equals where, like for example, before switching root, before after flashing image, before starting, and so on and so forth. And you can either have spawn or exec as the behavior. If you do exec, that's it, flow is cut. If you do spawn, you'll get a shell. You'll be able to do some things, and when you exit the shell, if you exit with a 0 return status, then the flow will continue. So look what I'm going to do in order to cheat here. I already mentioned that we're using busybox. And this means that if I go, and I know that the root file system, again, because I wrote it, is under mount system, it means that if I go now, and by the way, check out the OS release, Alpine Linux, everything is great. If I go now and take the inittab, I will see that it looks to do the OpenRC shenanigans. I can go ahead and modify these fellows if I want to. Okay. So I can just comment it out, and then I can just, then I will have, you know what, then I will cut it. Then I will have users, I will need to take care of the root username and root password. So I can share root to this system if I want to, and then modify it. But I'll do something else. I know it's busybox. I know that if I just remove inittab, there is a default inittab implemented inside of busybox. And this is what I'm going to do so that I auto login at root, and then I get it over with. So I'm doing this. I'll do sync so the changes are held. I'll go here and I'll continue. And there it is. This is like the ask first. Please enter to activate this console. I activated this console and everybody's happy. Okay. So I am in Alpine. I have the APK utility, and if I wanted to, I could go ahead and do IP link set up DHCP. They do have like some script here. I can do APK Add cmatrix. I like this example. Although I don't know if the terminal is okay now. And then I'll go cmatrix, and it'll go like this. And now I can see that the terminal type is not colorful. Why can I see it? Because I know it, and because it's this one. This is the default. This is also why they give it, hey, please put VT100 on the getty line. So now I'll just say, okay, no worries. Term equals Linux, and do cmatrix, and there we go, green, just like Morpheus intended, or just like the architect intended. Let's be accurate here. So this is good, this is great, but we needed to hack things manually. So now let's add some more things to our hacked system, and this is how we'll get like Alpine on board in nothing lines, like it's not even like a couple of lines. That's all like you need to do. Instead of the return, we'll do some more things, and then we'll get it done with. So let's just do it. So what I've done here, I actually overridden this function, build-distro and rootfs layer. Quick demonstration, modify hostname and version file is the same as what has been done in the other, on the Debian. I showed it like before, okay? And I actually ignore the other one, okay? So another thing that I actually skipped in the previous demonstration, I just skipped it, but on the original system that we did the copy, we had a build phase that clears the caches. So when I talk about the bootstrapping and optimizations, I also talk about cleaning them. But right now we're talking about implementing Alpine. Debian will get its own treatment once again in the upcoming embedded open source summit. They used to call it DLC. Now it's longer. Embedded Linux conference. Now it's different. So it took me time to remember. So this is what we'll do. We don't implement the rest of the functions. This is the return, but I do call one of the functions that is listed there, and this file is sourced. This is why the order doesn't matter. And here I did not remove inittab, but I just, instead of getty to I just do the bin sh. So yeah, it's 2 lines plus a little bit of relocation, but it was written like in a couple of minutes, just like to show how to hack some things. And I will rewrite it anyway. And I mean, if it's important for anyone, I'll do it properly, like with the Alpine downloading, with the caching, with the checking the signature for that, and so on. So it's done, and let's install it. So installed, good, and now I will run it. This time without stopping anything, and there it is, we're done. Okay? So this is our shell, and if we kill it, we can see there is a hold, and we can see that it responds. Why? Because we had put this line over it, okay? So we're good. Now we don't have cmatrix because we've never downloaded it, but we can redo it if we want. And this is how we add Alpine. So we do have like the package. We can set 88.0 up with HTTPC. In busybox OS, I show how to write the HTTP hooks that actually hook into micro DHCP client. But this is not here. And yeah, I mean, we have the APK, right? So these are like the list of packages that are currently installed. We can see that the muscle libc is used. So if you want to check all kinds of things with a libc that is provided for you, then Alpine does a nice work. It has the same busybox that I've been using, and everything is good, and everyone is happy. And happiness is very good. So yeah, we can install again cmatrix, and we can do all kinds of things. I don't know. I don't have GCC. No problem. No problem. I'll add GCC, and it will fetch all kinds of things and install them. There are dependencies. We have a package manager, and now we're happy. We're not We're not in 10 megabytes anymore. We're in 149 because of GCC. Okay, and that's how you can provision your things. And of course, you would add like a normal add layer file to make things like more organized. But if you just want a couple of tests, super easy. And I just gave a couple of explanations. Otherwise, it would take 2 minutes, the dark explanation. So that's it.